Hello children, welcome all those who are watching this video just the day before the exam. So we'll do the quick revision, no problem. We can save a lot of time. So first one is chapter 1, periodic table, periodic properties and variations. Straight away let's start. Important things, modern periodic law, what is that? The physical and chemical properties of elements are the periodic functions of their atomic number. What is modern periodic table? It's a simple tabular arrangement of elements. You are arranging them in groups which are vertical columns and periods which are horizontal rows, highlighting the regular trends in properties of elements. So you call that as periodic table. Important group names you have to remember, there are total 18 groups and 7 periods. Group 1 is alkali metals, 2 alkaline earth metals, 13 boron family, 14 carbon family, 15 nitrogen family, 16 oxygen family, 17 halogens, 18 which is also known as zero group, noble or inert gases. Zero group because the valency of noble or inert gases is zero. Atomic size, the first periodic property. What is it? It is the distance between the center of the nucleus of an atom to the outermost shell of the atom. See, this is the new atom. So this is the nucleus. So from this nucleus to the outermost shell, not the inner one. So that is known as atomic size. Second property is metallic character. So what are metals? So metals are those elements which have a tendency to lose their valence electrons. And when they lose valence electrons, they will form cations. So here you can see the valence electrons are lost. This property or this character is known as metallic character. And opposite of that will be non-metallic character, where some elements they have tendency to gain electrons in their valence shell, and when they gain electrons they will form what? They will form anion. So here if the fluorine is gaining electron and it is forming the anion, so this character is known as non-metallic character. Then ionization potential, which is also known as ionization energy, ionization enthalpy. So the energy required to remove the first two letters, when you see the energy required, so remember that it is ionization potential to remove an electron from neutral isolated gaseous atom. So remember this definition. So when you remove electron, what it will form? It will form positively charged gaseous ion. So again, it should be a neutral isolated gaseous atom, single atom. Okay. Next comes electron affinity. So opposite of that means it is the energy released. Okay, so when you see energy released, straight away it is electron affinity. When an electron is added to a neutral isolated gaseous atom, and when it is added, it will convert into negatively charged gaseous ion. So because of this is energy release, the value of electron affinity will be in negative, remember. And for ionization potential, it will be positive values. Next property is electronegativity. So electronegativity is totally different. For that you need to take a molecule, not isolated atom. So what is this? This is a simple tendency of an atom in a molecule to attract the shared pair of electrons towards itself. You take the example of HCl. So the shared pair of electrons between hydrogen and chlorine. So this will be only in covalent. Okay. So it will be towards chlorine because it is more electronegative than hydrogen, which is less electronegative. So this kind of bond is known as polar covalent bond. Then before we go to the trends, there are 2 points you have to remember or understand. Nuclear charge or also nuclear pull, it is known as. It is simply the positive charge present in the nucleus. What is that positive charge? The number of protons present in an atom. So what it does, it will pull the electrons towards the nucleus, and in a same period it increases from left to right. One more is number of shells. The number of shells or orbits remains same in a period, and new shells are added as we move down the group. Okay. Next, come to the trends. Very simple. When you take the atomic size, it increases down the group. Why? Because increase in the number of shells, more and more shells are added. And across a period, when you go, the atomic size, you can see it will decrease due to increase in the nuclear charge. So the reason also you should know, because sometimes give reason questions will also come. Next trend is about, see, all these three, ionization energy, electron affinity, electronegativity, they show the same trend. They decrease down the group and increase across a period. So decrease down the group, but it is going up here, so it is showing increasing. Bottom to top increasing, top to bottom decreasing. Simple. Left to right across a period increasing, all of them increasing. Down the group from top to bottom, they all are decreasing. The reason being same. Why? Because decrease down the group due to increase in atomic size, and increase across a period due to increase in nuclear charge and decrease in atomic size. Next, metallic character and non-metallic character. Remember that they are opposite. So if one is increasing, another one will be decreasing. So metallic character increases down the group and decreases across a period. Then opposite of that will be non-metallic. It decreases down the group and increases across a period. Reason will be same, whatever we till now studied. So important notes and some exceptions. Regarding the atomic size, you have to remember that cation is always smaller than its atom. Okay, and anion is always bigger than its atom. So atomic size order for x plus smaller than x, smaller than x minus. Exceptions are regarding electron affinity. See, inert gases. As I told you, electron affinity will be negative in value, but inert gases have 0 or positive values of electron affinity because of their stable electron configuration. Group 2 and 15, they are exceptions. They don't show regular trend of electron affinity values. And last important one, F, fluorine has lower electron affinity than Cl, and oxygen has lower electron affinity than sulfur due to smaller size of F and O. And because of that, there will be strong internuclear repulsion. Remember, if they ask you to write the decreasing order of electron affinity for halogens, okay, first what you will write, Cl, which is greater than F, greater than Br, greater than I. This is the decreasing order of electron affinity value. Don't write F first, because that is an exception here. Okay, so this is about the first chapter. Chapter number 2, chemical bonding. So first of all, why do elements form a chemical bond? Simple, all of them want to attain stability, so the atoms will combine chemically with other atoms by redistribution of valence electrons, so that all of them can get the stable electronic configuration. So then, which is stable electron configuration? Simple duplet rule means valence electrons will have 2 electrons if it is first shell. So it's only for helium and relevant atoms. And octet rule, where the valence electron will be having 8 electrons. So these are the duplet and octet rules. So you call such electron configuration to be stable electron configuration. How to achieve stable electron configuration? 3 ways are there. Okay, first one, you can transfer, not you, the metal will transfer its electron to the non-metal and form a bond which you call as ionic bond or electrovalent bond. Another method, when two non-metals share electrons with each other, mutual sharing of electrons, they will form covalent bond. One more type is sharing pair of electrons contributed entirely by one of the combining atoms, so they will form coordinate bond, which is also known as dative bond. Next important thing is electron dot structure of sodium chloride. So you can see here sodium electron configuration is this. When it loses electron, it will become stable 2,8. Chlorine will gain that electron and become stable again 2,8,8, form the chloride ion. So basically sodium will give its one of the electron to chlorine. This is the electron dot structure where you are showing only the valence electrons of the elements. So Na will become Na plus, Cl will have 8 electrons around it and become Cl minus. Electron dot structure of magnesium chloride. So magnesium will lose 2 electrons to become stable. It will form Mg plus 2. So to that we need 2 chlorine atoms to gain 2 electrons, and they will they will form two chloride ions and both will be stable. So here you can see Mg with cross electrons are shown, chlorine with dots electrons are shown. So one electron given to this chlorine, another electron given to this chlorine. So you will have two Cl minus ions and one cross you have to write like this, and Mg will become plus 2. Okay. Electron dot structure of calcium oxide. Again, calcium will lose 2882, so it will lose 2 electrons and become calcium plus 2 and stable. Oxygen will gain 2 electrons, 2 6 will become 2 8, again it will become stable. So you can write like this: calcium will give both of its electron to oxygen, it will become calcium plus 2, and you should not write this plus here. Okay, and oxygen will gain the electrons, both the electrons, and become O2 minus. So it is overall calcium oxide. Now comes types of covalent bond depending upon number of pairs of electrons they are sharing. If they share only one pair of electrons between two atoms, it is called a single covalent bond. Two pairs of electrons are shared, double covalent bond. Three pairs of electrons are shared, triple covalent bond. Examples you can see: hydrogen, chlorine, HCl, ammonia, all these single. Oxygen, carbon dioxide, and this is ethene, double covalent. Triple nitrogen and ethine, C2H2, ethine. Next, what are the difference between polar and non-polar covalent compounds? So, non-polar covalent compounds are those which, when shared pair of electrons are equally distributed between the two atoms, both will have equal distribution of shared pair of electrons. If it is not equal, one of the atom is pulling the electrons towards itself more, means it is more electronegative, then you call that particular covalent molecule as the polar covalent compound. Next point: in non-polar there is no charge separation takes place, but in polar there will be fractional positive and negative charge. So what happens if we take HCl? Cl will pull electrons towards itself, H will form plus and Cl will form minus. Okay, they do not ionize in water. Non-polar, they do not ionize in water. Polar, they will ionize in water. Electron dot structure of hydrogen molecule. Simple, these are all non-polar molecules what you are studying first. H will have one electron, both will be shared between the two atoms. So it will be single covalent bond, it will be non-polar. Electron dot of chlorine molecule. So chlorine has 7 electron, both will share one pair of electrons. And whatever left here, you call them as, these all as lone pair of electrons which are not shared between the atoms are called as lone pair. So there are total 1 2 3 4 5 6 lone pairs. Okay, and all of these are single covalent bonds, so it is a non-polar molecule. Nitrogen molecule, it will be having triple bond between nitrogen and nitrogen, triple covalent bond. This is again non-polar molecule. So you can see here one lone pair on this nitrogen, another lone pair on this nitrogen. So there will be total two lone pairs. Dot structure of carbon tetrachloride molecule, one carbon and four chlorine atoms. So they will form the four single covalent bonds. This is a non-polar molecule. The important question here is, even though the carbon and chlorine has different electronegativity, why this molecule is non-polar? Okay, so because of symmetrical structure of symmetrical structure of carbon tetrachloride. So what happens? The all chlorine atoms will pull the electrons towards themselves, but that is in all of them pull the electrons equally but in opposite direction. So total net effect of pulling will be 0. Therefore there is no partial positive and negative charge formation here, hence the molecule is non-polar. Electron dot structure of methane molecule. So here carbon and four hydrogen atoms, so they will share the electrons and form four single covalent bonds. And because the carbon and hydrogen has very less electronegativity difference, it is a non-polar molecule. Water is a polar molecule. So oxygen and hydrogen, two hydrogens. So it will form this structure. Okay, and Why it is polar? Because oxygen is pulling electrons towards itself, so it will have a slight negative charge, and hydrogens will have slight positive charge. So there is a bipole formation. So it is a polar molecule. Ammonia is again a polar molecule. Nitrogen 5 electrons, hydrogen 1 1 1. So there will be one lone pair of electrons left on nitrogen. Okay, and this is again polar molecules. This is a structure of ammonia. So nitrogen will have a slight negative charge, all the hydrogens will have slight positive charge. What do you mean by lone pair of electrons? Lone pair of electrons are the valence electrons that are not shared with another atom in a covalent bond, and is sometimes also known as unshared pair and non-bonding pair. So what are the molecules with no lone pairs of electrons? Hydrogen and methane. And all other molecules contain lone pair of electrons: chlorine, nitrogen, CCl4, water, ammonia, all of these. What is the difference between ionic compounds and covalent compounds? Definitely one question will be there. Ionic are hard solids, and they are gaseous, liquids, or soft solids, which are covalent. High melting and boiling point for ionic compounds, low melting and boiling points for covalent compounds. Ionic compounds are good conductor of electricity in molten state and aqueous state, not in solid state. But covalent compounds, they are non-conductors of electricity in solid, molten, as well as aqueous state. They consist of ions. When you dissolve them in water, ionic compounds. And covalent compounds, they consist of molecules. They undergo dissociation in solution. You call it as dissociation, ionic compound dissolving in water and forming ions. Whereas if a polar covalent compounds form ions, you call it as ionization. In electrolysis, we are going to learn this. And ionic compounds, they're soluble in water. Non-polar covalent compounds, they are insoluble in water, but polar one, they will be soluble in water. Last part, coordinate or dative bond. What do you mean by dative bond or coordinate bond? The bond formed between two atoms by sharing pair of electrons, but the condition here is the both shared pair of electrons are given by one of the combining atoms, but they are shared by both. So conditions here, one of the two atoms must have at least one lone pair of electrons, and that you call as donor. And another one should be short of at least a lone pair of, sorry, at least a pair of electrons, you call it as acceptor. Next, electron dot diagram of hydronium ion. So first you have to write for water, we have already written that. Then H plus is the donor, acceptor, water is the donor, so one of the lone pair will be given to H plus. So then you write this structure, hydronium ion. Don't forget to put this square bracket and plus. Then finally you can write the bond line notation here for hydronium ion. So this is the electron dot structure or diagram of hydronium ion. Similarly, electron dot diagram of ammonium ion. Ammonia you write first, electron dot diagram, which we already saw. H plus is again the acceptor here. So one of the lone pairs will be given to H plus and it will form NH4 plus. First you have to write all the dot diagrams here. Then you write the notation with bond line notation. What this arrow mark represents? That represents the coordinate bond. So it has the coordinate bond as well as covalent bond. Very important question. Name the type of bonds present in ammonium chloride. Not only ammonium chloride, any ammonium containing compound. So ammonium sulfate, ammonium nitrate, all these, ammonium hydroxide. So all these compounds have all the three types of bonds. What are those? Coordinate bond, covalent bond, and ionic bond. Remember this point. So then we'll meet in the next session. Until then, take care. Bye bye.